Okay, in this lesson we're going to be breaking it into two parts. We're going to focus first on just classifying polynomials and a couple other vocabulary words related to polynomials. So first, a polynomial is just an expression that has one or more terms. And we're going to look at lots of examples below. But there are also a couple things that are not a polynomial. So we have some rules that follow for the terms. Those terms cannot have any of these things. So if it has these things, there's not a polynomial. So it can't have negative exponents. It can't have decimal or fraction exponents. And it can't have variable exponents. And then we don't want the variable under a radical or absolute value or anything like that. So any of those would be considered not polynomials. So basically we just want, it could be a number, it could be a variable by itself like x, or it could be to some exponent, x to the second, x to the third, x to the fourth, x to the fifth. Just no negative exponents, no fraction decimal exponents. The variable cannot be an exponent. That's what we just did. Those are exponentials if the variable is the exponent. Okay, so let's look at standard form next. So if a polynomial is in standard form, it has the largest degree first, it's alphabetical, and then the constant is at the end. A constant is a number by itself, so like 5 or 7. Constants are numbers by themselves. So it says largest degree. So let's go back up to degree. What is a degree then? So we take the biggest exponent, and that makes up the degree of our polynomial, unless there are two variables, like x to the second, y to the second. So we have two variables. In that case, you add the exponent. So you look for alphabetically, you're going to look for the biggest exponent. And then once you find that, the leading coefficient is the number attached to the degree. Okay, so hopefully this makes some more sense once we get into those examples below. Let's actually go ahead and skip down to some of these examples now. We'll come back up and finish this table in a second. So find the degree of the polynomial. So on the m, the exponent is a 1, so the degree would be 1. It's a first degree polynomial. And then on number 2, the x is the largest exponent with 5, but because there's a y also, we're going to add those together. And that's going to be 8, so it's an 8th degree. So degree is 8. And then on number 3, degree is 0. Because technically we can put like an x to the 0 here. Remember, anything to the 0 power is just 1, so that ends up just going away. But it does exist there. So degree is 0. Number 4, the degree is 4, so it's a 4th degree. And number 5, exponent 3 here is bigger than the exponent of 1 here, so it's a 3rd degree. And the x squared is bigger than the x to the first, so that's 2nd degree. And we're not going to be looking at a whole lot like number 2. We're really going to focus on all the other ones. And when we just talked about this, we're just looking at like first degree, eighth degree, third degree. But we actually have names for these. We're only going to really learn the first few names. And after that, we just are going to say other polynomial. So if it's 0 degree, like on number 3, where it's just a number by itself, a constant, any kind of number by itself, it's just a constant. If we have the first degree, like on number 1, we call that linear. Second degree, we call quadratic, which we will get into quadratics in the rest of this unit and then looking forward. And then third degree is a cubic. And there are names past that, but not names that we are going to need to memorize. So these are the only names we're going to need to memorize. So if that biggest exponent is a 3, cubic. 2, quadratic, 1, linear, or if it's 0, it's a constant. And then we're also going to name these based on how many terms they have. So if they have one term, and let's make a note down here, terms are separated by addition. Sort of subtraction, because you can turn a subtraction problem into addition. So you want to turn it into addition to really see the separation of the terms. So you're counting how many things there are separated by plus signs. If there's no plus signs, just a single term, that is called a monomial. And that word mono, that prefix mono, means 1. If it has 2 terms, for example, if we have 2x plus 1, so there's 2 terms separated by a plus sign, that is a binomial. And there's that prefix bi means 2. 3 terms is a trinomial. Prefix tri means 3. And then again, there are other names, but we're not going to practice those right now. So we'll just refer to everything else as other polynomial. Or we're going to say polynomial in general, covers everything. So these are the vocab that we will need to know that will be quizzed and tested. Okay, so let's look at how we can apply these to some practice problems. We're going to write each in standard form, so biggest exponent all the way down to constant at the end. And then we're going to state the leading coefficient and classify. So let's write them in standard form first. So the biggest exponent is that 3x squared. The next one is a hidden 1 here, so then there's a plus 8x. And then the 9, there's that hidden x to the 0, so that goes at the end. Number 8, we want the biggest exponent first, so that's going to be the 2y to the 3rd. And then we have the minus 7, or I could say plus negative 7. And we're going to leave that 3x squared. Then I want the 5x, because that's really 5x to the 1st, so 2, 1, and then 0. And we have negative x, because again, that's x to the 1st. And then a positive 7, because there's technically x to the 0 with that. And then 3 is just 3, that's an easy one. And negative 9m is only, so these last two are only single terms, so there is nothing to order. Okay. Now let's look at the leading coefficient. So we're going to state the leading coefficient. I'm just going to say leading. So the first term here is the 3x squared. That 3 is the leading coefficient. It's the number in front of our first term, or the number attached to our first term. So our leading coefficient here, the first term is this 2y to the 3rd, so we want the 2. The 2 is our leading coefficient. The 3x squared is our leading term, so the leading coefficient is the number 3. And then in number 10, our leading term is negative x. Remember, there's a hidden 1 here. So our leading coefficient is really negative 1. There's only one thing on number 11, so our leading coefficient is 3, because technically that's attached to an x to the 0. And the leading coefficient on number 12 is negative 9. So again, it's going to be that number that's attached to our first term in standard form. All right, and then the last thing that we're going to do is we're going to classify by degree in terms. So basically we're going to pick one thing from this first column and one thing from the second column. So this one is the degree, and then we'll pick the term. So number 7, this is a second degree. It has an exponent, biggest exponent is a 2, so it's going to be quadratic. And then it has 1, 2, 3 terms. So 3 terms is a trinomial. So it is a quadratic trinomial. Number 2, our biggest exponent was a 3. So that's going to be cubic. And it has 1, 2 terms. So if we go over to the terms, 2 is a binomial. So it is a cubic binomial. Number 9, our degree is a 2. And 2, if we go back up to our degree, that means quadratic. And it has 1, 2, 3 terms. So just like before, that's a trinomial. So a quadratic trinomial. Number 10. There's a hidden 1, so our exponent is a 1. 1 was going to be linear. And it has 1, 2 terms, so that's a linear binomial. Number 11, there's just a single term here. It has an exponent of 0, so that's going to be just a constant. When it's a plain old number by itself, it is a constant. And because there's just that single term, it's a monomial. So a constant monomial. Number 12, the m has a hidden 1 on it. So 1 was linear. And because it's just one single term is a monomial. So linear monomial. So definitely practice those vocabulary words, and we'll be practicing in class as well.